Alright guys, now comes from the part that you have not ever done before. Going to need you to really kind of pay attention and take my word for what I'm about to show you. What I'm about to show you is really some fundamental calculus. Without using a graphing calculator, we cannot find the relative max or relative min by hand without using calculus. At least I don't know of a way that's really effective. Other than that, we could always estimate it if we had the graph by doing halves and halves and halves. But believe it or not, that is calculus as well, finding the slope of a secant line. So what I'm actually going to do is I'm going to do the power rule, and I know this looks confusing. It says if f maps to from the reals to the reals is a function such that f of x equals a times x to the power of r, and a cannot equal 0, and f is differentiable at x, then dy dx, or f prime of x, is your r, your exponent, times a times x to the power of r minus 1. And of course the sum rule says that d dx times u plus v plus w, this really just means terms, is that you can do the individual derivative of each term. In this case with polynomials, we can just do the power rule over and over and over again with each term. And then we are going to do the first derivative test for trying to figure out where it's increasing and decreasing and find your relative max and relative mins. So here we go. We're just going to dive right in. I'm going to do number 15 right here. And this is going to be multiple steps, so try to stay with me here. If we have f of x equals 3x to the fourth minus 4x cubed minus 12x squared plus 3. Right off the bat, I would know from experience from curve sketching that I know my end behaviors are both going up. I also know that the reason why it's going up is because my degree of the polynomial is even. I know I'm going to have 3 turning points. My leading coefficient is 3, which helps me determine if it's going up. I already know my y-intercept. I can find my x-intercepts. That'll be a little dicey, but using the rational root theorem and the remainder theorem and reducing it with using polynomial long division or synthetic division, I'll be able to get to a quadratic where either I can factor use the quadratic formula. Pretty lengthy process. But really the key part, this is going to help you find the turning points, your relative max and relative mins. So the first thing we need to do is we need to apply the power rule. The power rule means we're going to take the derivative. So we're going to do f prime of x. So we're going to do f prime of x. And what that's going to allow us to do is take my exponent, 4 times 3, x to the 4 minus 1, minus 3 times 4, x to the 3 minus 1, minus 2 times 12, x squared minus 1. And of course then really this 3 to the, it's really x to the 0. So if you wanted to think of it in those terms, you can actually think plus 0 times 3, x to the 0 minus 1, which this is just 0. And there is a rule that says that if you take the derivative of any constant, it is 0. And now let's clean up our math. This is going to give me 12x to the third minus 12x squared minus 24x. This is your f prime of x, or your derivative. What this actually does, it gives you an equation to find the slope of any point on the line or on the function 3x to the power of 4 minus 4x cubed minus 12x squared plus 3. This formula right here will give you the slope of the tangent line of any point on that graph. Now, my relative max and relative mins, what's really nice about these is at that point where it's a relative max, relative min, your slope is actually 0. So we're actually going to solve this by setting this equal to 0. So we can go 0 equals 12x cubed minus 12x squared minus 24x. This is just algebra. You've been doing this since algebra 2. So we're going to factor out our greatest common factor. So we're going to have 0 equals 12x, and that leaves me x squared minus x minus 2. Well, we still need a factor to get it completely factored, so we're going to do 12x, and this becomes x minus 2 and x plus 1. From here, we set each term equal to 0. This is just your basic algebra. We get 12x equals 0, x minus 2 equals 0, and x plus 1 equals 0. When we solve this, we can see that x equals 0, x equals 2, and x equals negative 1. Now, these are not x-intercepts, because in the past, what you've done in algebra is when you set it equal to 0, you find the x-intercepts. But in this case, this is actually calculus, so you're actually finding at what point, at what x values of the point is the slope 0. Now, what that tells us is it's going to be a relative max or a relative min, but what we actually have to do is do the first derivative test. And that's where, right here, it says, let f be continuous on an interval I and is differentiable on the interior of I. If f prime of x is greater than 0, this upside down A means for all x in the interval I, then f is increasing on I. If f prime of x is less than 0 for all x's in the interval I, then f is decreasing on I. Well, if we know where it's increasing, decreasing, we can also figure out where our max and mins are. So the first derivative test, this is going to look familiar as well to you. This is actually going to look just like when you do inequalities. So what you actually do with inequalities, you go ahead and put yourself a number line down. You're going to put all your critical points being -1, 0, and 2. You're going to pick test numbers to the left, in between, and to the right of everything. So I'm going to do -2, -0.5, 1, and 3. And then what I'm going to do is I'm going to evaluate. I'm going to do f prime of -2. When I do that, the answer becomes -96. I just plug it back into my derivative. I do f prime of -0.5. When I do that, I get 7.5. When I do f prime of 1, I get -24. And when I do f prime of 3, I get 144. Now, the way I set up my first integral test is maybe a little different how you see it in books or how it's done in AP Calculus, but this is pre-cal, so we're just doing really the basics of this calculus. I know right here my slope is negative. That means as the graph's coming in, it's got to be going this way. Here, between -1 and 0, with a 7.5, that means this is positive. That means that graph needs to be going this way. At 1, it's negative. That means that graph is coming this way. And then after 2, at 3, is positive, so that means the graph is going this way. So here I can actually write my points. I know that I'm going to have a relative max and relative min. Looking at my arrows here, as I'm going down and then back up, the -1 is going to be a minimum. So my relative minimums is going to be at -1 and f of -1. Now you put this back in your original equation, and you will get -1, -2. Also, as you see here, we're going down and then back up for our slope. We're going to have another relative minimum at 2, f of 2. So you put 2 back into your original function. You're going to get a point of 2 and -29. So now I have 2 points. Those are my 2 relative minimums. My relative maximum as you can see from here, here it's going up and it's going to come back down. So our maximum is going to be at 0. So we're going to do 0, f of 0, which now becomes 0, 3. So now I have the points of my relative max and relative mins. Now the last thing is to figure out where in the world is this graph increasing or decreasing. Well, this actually tells us that our first integral test actually tells us you can see that right here, this minus, it's decreasing from negative infinity all the way up to -1. And then it's going to be decreasing again from 0 to 2, because we're going to use our x values and our x values only. So for the decreasing, now of course we can never touch infinity, and this is interval notation, so we have to use our curved bracket. And it's important to understand that at -1, there actually is no increase or decrease because the slope is 0, because 0 is neither negative or positive. So we're going to do -1. We're going to do the non-inclusive parenthesis. We're going to do our union, and we're going to jump over to our next interval, which is going to be between 0 and 2. And of course, we don't touch those. Where we're increasing at is we're going to be increasing from -1 to 0 and from 2 to infinity. So my increasing is, of course, we don't touch our points either, is -1 comma 0 union 2 comma infinity. So this is actually a way you can tell where it's increasing and decreasing and find our relative max, relative mins. Now, what we're going to be doing next is we're going to talk about synthetic division, a polynomial long division, a straight review from Algebra 2, and then we're actually going to sit and graph using everything that we've talked about. Use everything to graph so we can find all of our points, our x-intercepts, our y-intercepts, our relative max, our relative mins. Where is it increasing? Where is it decreasing? The end behavior. And actually graph a polynomial without having to use the parent function and transformations, or, and more importantly, not having a graphing calculator in your hand.